All right, we're on to 4.5. This was our parent functions, right? So we had two parent functions. First, we need to talk about what a function family is, right? So a function family is functions that graphs and forms look the same. So this was our, f of x equals x is our parent function for the linear functions. Then we had our absolute value functions. And our parent function for that was just f of x equals the absolute value of x, okay? And these are our simplest forms, because when we graph them, I graph the top one, end up with that, I graph that one, I'm gonna end up with that. And this is our reference point, it's our parent function, because it's the simplest. What I plug in for this, I get out. So I plug in 1, I get 1. I plug in 2, I get 2. So on and so forth. Same, I plug in 1, I get 1. I plug in 2, I get 2. I plug in -3, I get +3. These are our simplest forms. We then talk about transformations. So we had 3 types, right? We had translations, dilations, and reflections. Okay? Translations was when we moved it left or right, or up and down. And the terms we used for that were slides and shifts. You can use slides for all of them, you can use shifts for all of them, I don't mind. Then we had dilations. So first we had it when we stretched it nice and vertical, and this was our stretch. And then we had compression, where we made the slope. Let's make that more obvious, right? This is the compression. And finally, we had reflections. This is where we flip it. So it goes from this to this. Like we're looking at a reflection in a mirror, okay? So if I were to give you f of x is equal to 2, let's make it -2 times the absolute value of x minus 3 plus 2, okay? And then asked you, how do I get from my parent function this to what's eventually going to be, let's see, that. How do I get from there to there, okay? I like to go step by step. So first I decide, are there any slides or shifts? First we find our vertex. I'm just going to use the shorthand. We all know it already. So I know that this is going to be +3. So first I slide 3 units to the right. Okay? So now I've taken this V and I've moved it 3 over. So then, because it's like telling a story, how did you get from here to here? It's like given direction. Then I'm going to shift. Also, we're just going to make that negative since I already drew it as negative. I wasn't really paying attention. Shift down 2 units. Okay? So now I've gone from here over 3 down 2. I like to go in order. So next would be dilations. Well, I'm going to dilate it by stretching it, okay? Because my slope is increased. So then I'm going too much into it. All right, so then stretch, and it's vertically, and this is important, you must have that it's a vertical stretch, because there is such a thing as horizontal stretch. And it's by a factor of 2, okay? By a factor of 2. When you hear factor, what do you think of? Multiplication. And that makes sense, right? Because now every time I plug in, I'm increasing by that factor of 2. I'm doubling what I would have got if it was just my parent function. Finally, do I have any reflections? Yes. So then, reflect over the x axis. Okay? If I were to follow these steps, take my parent v, slide 3 to the right, 2 down, stretch it vertically, and flip it. We look over there, bam, there's my new function. So we can also do these with regular functions, but to keep it easy, I'm going to keep it with the absolute values because you can see that v really change. If I move that line, it just kind of looks like I'm moving it wherever. This v, my vertex really moves around, so that's why all the examples are going to use vertexes, or absolute values. So hopefully this helped. I got one more lesson, which is good because I'm about to lose